Okay, let's get started. Welcome everyone. I'm Jonas, working for EclipseSource, and I'm also the project lead of EMF Forms. And today I would like to talk about EMF Forms. It's a getting started talk, answering the most important questions that typically come up for new users getting started with this technology. So first important question, who of you knows EMF Forms? Perfect. Only one. Okay, you are in the right talk. So the idea of this talk is I will quickly explain the motivation, how we came up with the framework, and then I will switch over to a demonstration. And this demonstration is really focused on showing you the first most important steps and also answering the first most important questions that we typically get via email, via newsgroup, and so on. So hopefully after this talk, you should be able to get into the framework more easily, and also you know more precisely what it does and how it can help you. Okay, so what is EMF Forms about? In almost every application, may it be a tool or a business application, some data is presented and edited in some form-based UI. You could edit some preference, some business data, customer data, whatever. So this should look familiar to every one of you. Common scheme is that you have controls presenting data, and you have to arrange those controls somehow in a layout. Now, it's actually, and it doesn't really matter whether this is on the desktop or in the web or even on a mobile device. In every of those areas, you have form-based UIs. Now, it's surprising to see how much effort it is to manually code those forms. And if you get started with this, it always sounds very simple to just code a form-based UIs, but you end up with a lot of code. So let's take a simple example. The most simple form that we can imagine, just with one control, a label, and a text field. So how much code is that? If we do that in SWT using data binding, we end up with this. You might be surprised by the amount of code, but it's not only creating a layout for those two things, it's creating a label, it's creating the text field. Then you need to bind the data, and if you want to provide input validation, you also need to attach some adapter which will validate the string that the user has entered. So that's pretty much the code for one control. Now, if we drive that further, if we now extend our form a bit, let's say to 4 controls, then let's assume we don't need to re-implement this because we can somehow reuse that. We have to add the layout, and the layout for this would look pretty much like this. And we have to deal with grid layouts, with spans, with grab access space, and so on. So it is a lot of work. Actually, statistics show that in typical business application projects, 40% of the effort are spent in implementing the UI, which is a surprising number because we always believe, okay, we focus on business logic, on interesting stuff, but not in implementing form-based UIs all over again and again. And finally, I don't know a single developer who actually likes to implement something like this because it's very recurring. Is there somebody here who likes to implement this? Don't be shy. Okay, so the goal of EMF Forms is to make that better. So instead of writing all this code, what EMF Forms provides is a very simple declarative language to describe your form. So let's go back to the simple example. If we just need one control showing the attribute first name, in EMF Forms we just need to specify that. So we have a top-level element which somehow says, okay, there is a view, and then we have an element of type control which specifies we want to show the first name, the attribute first name. Very simple. All the other stuff, like that there is a label, that there is a text field, and that this is bound to the attribute, plus the validation, can actually be derived from that because it's always the same. We just need to know which attribute to show. And of course, the scales. Now, if we extend the example again to those 4 controls, we just need to repeat that 4 times. Now, this is still a simple example. Of course, we have to deal with layouts too, but that's the basic idea. Now, to bring that in context, if you want to use EMF Forms, you need 2 things. One is a definition of your data. That can be done in any data definition language of your choice. So the default way would be to do it in eCore, which is the data modeling language provided by EMF. But you could also use XSD or UML or whatever you want to use, because those formats are migratable. So you can transform an XSD into an eCore, for example. Now, this artifact describes the data that you will show in your form-based UI. So which attributes are there, what constraints are on those attributes, and so on and so forth. And now EMF Forms adds a second artifact that we call a view model. This view model only describes the form-based UI, pretty much following the same scheme that I had on the last slide. And now we have two models, but not a running form yet. And that's the responsibility of a renderer, also provided by EMF Forms. So during runtime, the rendering component consumes the data model and the view model and renders a user interface. If you're familiar with web application, that's pretty much like a browser renders HTML. Pretty much like that. Okay, so let's directly dive into the demonstration as promised and answer the first most important question, is how to get started. So let me switch to my Eclipse IDE. The only thing that I prepared for this demonstration is the data model, meaning the data entities that I want to show in my form. Because that's not really related to EMF Forms, and typically if you start to use the framework, you somehow have those entities already. They could be derived from a database using XSD, or you could model them in UML. Even if you have plain Java beans, you can actually derive this definition from the Java code. Now, in my case, I have an EMF model. If you're not familiar with EMF, what this bundle basically contains is entity classes. So, for example, here we have a class user, and let's look at the outline of this. So this is a entity class, as you would expect. It has attributes like get name, set name, get last name, set first name. So those are the attributes that I want to show in the form-based UI. What we also have in this bundle is the formal definition of this model, because the code that I've just shown is actually generated from that. And this model can be found here. It's an eCore file. Now, this simple example model contains 3 example entities, a task, a user, and a user group. In my demonstration, I will only focus on the entity user, which is just an example of an entity describing a person. And as you can see, it has, here we see the same attributes: first name, last name, gender, active, time of registration. Those are just example attributes, so I can use those attributes to be shown in a form-based UI. Okay, so let's create a form for this data entity. EMF Forms provides a wizard that you can directly derive the first version of your form from the data model. What I will do now in the remaining part of my demonstration, this is all available in the classic Eclipse modeling edition, so you can just download and do that yourself. So I didn't install anything new. Okay, so to create my first view model, I do a right-click on my data model, and there's a context entry EMF Forms, which allows me to create a view model project. This will actually create a second bundle, because we want to keep the definition of our UI separate from the data model, because that's not really related, and we want to separate concerns. It suggests me a name, so I will use the default name. Now, on the next page, it already processed the data model. As you can see, it shows me the 3 entities that are defined in my data model, and I can now select for which entity I would like to create a form. As mentioned before, I want to take the user. And there's another option on this page where I can influence whether my first view model will already be filled with a default layout. The default layout is also derived from the data model. It will just add a control for every attribute. That means my first form will just show all attributes which are in the data model. Okay, and then I click on Finish. And now my first form is fully defined. That were 3 clicks. Now, what you can see here, that's the view model I've talked about before. At the moment, it's the simplest view model that you can imagine. We have a root element, which defines that this presents a user entity, and we have a control for every attribute as defined in the data model. Now, before I go into detail about this artifact, this is not really very impressive because I just have a strange thing in an editor. Of course, I want to see how does this look like as a form. And that's why EMF Forms, of course, provides a preview for this form. So I can open up this preview. And now we really have the form. So this is now how EMF Forms renders the UI, consuming the data model and the view model that I've just created. And I would show how to embed this into an application later on. What's worth mentioning is that this form or this preview is already fully functional. So if I enter something here, this is already bound to the underlying data model. And one example where you can actually see that is that the last name attribute is marked in red. And the reason for that is that in the data model, it defines that the last name is a mandatory attribute. And this is automatically picked up. So the UI automatically validates this constraint. Now, if I add something here, the validation error is gone. Other things that this automatically picks up from the data model is, for example, that gender is an enumeration. So it shows me the possible values defined in the data model. It knows about the data types. So, for example, it knows that active is a Boolean, the time of registration is a date, and so on and so forth. So those are very often things that you need to redo once you program a UI for a data model, but actually the data model already contains all this definition, so we can just derive it from there. Okay, and finally down here we see a reference control. This actually shows a list of tasks for this specific user. The reason that we have this here, that my data model describes a reference to another entity called task. So we can also handle references here. Okay, so let's switch to the next question. What about layouts? At the moment, we have just a flat layout, just a plain list. And while it's nice to play around, if you want to use that for your application, obviously you need some layout capabilities because complex forms cannot just be presented as a flat list. Now, so far, our view model just contains controls. Control is the first of two types that we support in the view model. A control always represents an input field. There is a second type, which is called a container. And container allow me to structure the controls and thereby produce a layout. It's again pretty much like HTML does that. And the nice thing is I can also use this editor to create those layouts. So as for example, I can add a horizontal layout as a top level element. And now I can create another container called group. I will call this group left. And another group called right. And now I can just drag and drop an arbitrary number of controls in here, and maybe those into the other group, and maybe remove this because it doesn't really fit in. And now let's refresh the preview. I have to excuse the resolution of the screen is really bad. It's only 1024, but as you can see, we have now two groups next to each other, and we ordered all the controls in a very simple layout. Now, the same way you can continue to produce more complex layouts, and there are quite a few layouts provided by EMF Forms. However, the layouts that we provide are not on the same level as, for example, SWT or JavaFX does that. And the reason, so we don't have, for example, a grid layout. The reason for that is that we don't support any type of UI element in there. We know that there are controls, and that makes things much easier. For example, in our standard layout down here, we don't have to define two columns. We basically just have one column because we know that there is typically a label there. The other reason that we don't have too many layout concepts is that we rather render them differently. And that basically means, for example, a group. Group basically means all the contained elements are somehow grouped together. That doesn't necessarily mean that we have to draw a border around them, but it could also mean that we'd render those things as a collapsible section. And those things I can actually configure. So for example, in my group, I can change the group type to collapsible. Let's do this for the other one too, like this. And now let's refresh this. And now we can see I can actually collapse the groups just by changing the way that this is actually rendered. Okay. So let me switch back to the next question. Sorry, one thing that I forgot. If I do a right click here, this is the total list of elements that we have. This list has been developed over 7 years now, and I would claim we reached a state where we can actually model any kind of form-based UI using those concepts. If a custom project wants to do something differently, it's rather an adaptation in the rendering component to display the same concepts differently. By the way, this is again, if you think about HTML, we leave the HTML tree as it is, but we apply a different CSS to just change the way that stuff is presented on screen. Okay, so let's switch to the next question. Now, so far I've shown you a tool in my IDE. And we have a preview, and this looks all very impressive. But how do I embed this now into my application? Because at the end of the day, I want to have this in my application, not in the IDE. I need this, I need to embed those forms. So let me demonstrate that. To embed my form now into an application, I need an application. And what I will do is I will instantiate an example application that also ships with every Eclipse modeling edition. So you can do that clicking New Example and then Sample E4 application. This is the simplest application that you can imagine. It just opens a window with one view, and this view embeds EMF forms in it. So let's look at the code. So as you can see, this application just defines one class. That's this view, the one and only view. And let's open this. So it contains two methods. The first method up here creates an entity object, meaning the data object that we show in our application. In our case, it creates a class of type user, because we need some data entity to bind our form to. And now the second method creates the actual UI. Now, those 4 lines here are not really related to our form. They just create a border in which we can place our form. So if you look at this, we create a composite, we set the color, and we add some margins to this composite. So this is not yet the form. The interesting line is this one. We call the EMF Forms renderer and the method render. And the 2 parameters that we need is first the parent composite to place our form on, and second the input object. So only 2 parameters and only 1 call. And now if we start the application, let me save this and run. We see we have exactly the same now in a running application. And that's the way how you can embed it. And as you only need as a parameter the parent SWT composite, you can embed EMF forms at any place in the application you would like to. In a dialog, in the preference page, in the view, a subpart of a view, wherever you want to use it, you can actually embed it. You might wonder why we only need 2 parameters, because an obvious third parameter would be the view model. The reason that I don't necessarily need this parameter is that all view models are automatically registered at a central registry. And if I don't pass a view model, it will look in this registry for a view model for the type that I pass in. So if you just have one view per type, you don't have to explicitly pass the view model. If you have several different presentations for the same type, you can, in an overloaded method call, you can also pass in the view model explicitly, if you like. Okay. So heading over to the next question. Now, typically the next question after having this, so projects get started with a default form, they use the default layouts and default controls, and then they embed those forms into the application, and everything works fine until you get the requirement to replace a certain control or have something rendered differently. As an example, you might not like those collapsible groups that I've shown, but you might want to style them differently or use another UI element for that. As another example, you might, instead of just modifying plain strings, you might have hex values in your domain model. So you might need a hex string editor, which only accepts A to F and 1 to 0. Now, the question that we often get is, or the comment that we often get, I would like to use EMF Forms, but I'm not happy with the default controls. Now, the good news is you can replace every single part which is actually created in the UI, because the renderer component that I had on my third slide, this is not one big class which completely processes all the view model, but in fact there is one renderer per view model element, or more precisely, there can be even several renderers for every view model element. And you can decide very precisely which renderer will be chosen to render which element. And now you can use this mechanism to plug in your own renderer. And then you have to write some lines of UI code, and thereby you can add your own custom controls and your own way to render layouts very easily. And that's actually even the default way of using EMF Forms. What typically happens is that initially people use the default controls and the default layouts, but sooner or later they add their own controls and own layouts, and that's completely foreseen. The good thing is you never have to change the view model, you just exchange the rendering component. So let me show you how that looks like. Now, again, I will use an example that ships with every Eclipse instance, and I will show you the code inside. So again, I click on New Example, and what I will do is I will exchange the way that groups are rendered. Groups are the elements which draw currently the border around the controls. Now let's instantiate this bundle. And now let's have a look inside. So a renderer consists of two pieces. The first one, that's the element that we call a renderer service. This one is responsible of plugging in your UI code into the framework. And the main the one and only responsibility of this class is to decide when your new renderer is used. And therefore, it has one method, which is called isApplicable. This gets in the current element to be rendered. In our case, this would be a group, and a context where you can actually browse for additional information. I will not go into detail for that. And now what we do in our group renderer is we check whether the element, the view element, to be rendered is a group. And if so, we return a high priority, because this decision is based on priorities. And if it's not a group, we return not applicable, which stands for -1, so our render will not be called. So this is the decision. I show you this because, so this decision is very simple. This will replace the group renderer completely, and only this renderer will be used for group. However, you can have more sophisticated checks. So for example, you can render groups differently if, I don't know, the text starts with a P, or you can render certain controls differently if they, I don't know, have a length of 8, or if they are of data type hex string or whatever. So you can pretty precisely control when which renderer is going to be used. Okay, now let's go to the real rendering code. That's the second class in here. And let's look at the interesting method, which is the render control method. Now, this is the method which actually adds your UI code into the framework, and where you create the UI elements that you want to be rendered when this renderer is called. So what does this do? First, we set a background to be inherited from the parent element. And now this is the most important line. We instantiate a P group. P group is an alternative to the standard SWT group. It's an element provided by Eclipse Nebula. So in a nutshell, it's just another group implementation. But we could do whatever we want here. We set the text of this group to the text which was defined in the view model. That's happening in those 3 lines. And finally, what we do down here in this listener is the P group is one of those group elements which can be collapsed. Now, if we collapse a group, the parent layout needs to be adapted, because that can free some space, and if there's a container around this group, it has to shrink too. And that's exactly what we do here. And as we can see, there is a helper for that. So we just need to tell the framework, we have potentially changed size. Please relay out the form here. Okay, so let's run this. Before I restart the application again, what I need to do now is I need to add this renderer to my run configuration, because there's no dependency from the application to my renderer, and consequently it would not be picked up if I not manually add that. And now let's restart the application. Oh, it's still running. And now we can see we have replaced the way that groups are rendered. And I can collapse them, and they look very differently, just by plugging in this one class. The nice thing about this architecture is that you can really very iteratively, step by step, adapt your application. You will have a running form from day one. You can present it to customers. They can try it out, and then they can say, okay, I want this control differently, this group differently, and so on. And you can really step by step do that. One huge danger about this approach is don't show this to management, because if you show it to management on day one, they will consider project to be done, and they will remove all budget. Seriously, be careful with that. Okay, so let me switch back to the slides. Now, the final question in this presentation is a wide one, because after those 5 questions that I've just answered, every user has a different question, and that typically starts with, does EMF support this or that or this or that? And the good news is, since we developed the project since 7 years now, and it has quite a few very large projects using it, the likeliness that the answer to this question is yes is pretty high. So it's worth to check it. To give you some examples, typically a highly required feature is rule-based visibility. That means if user selects A in a certain control, then this whole section is not visible anymore, or it's not enabled anymore. So we can describe this in the view model, and it's fully supported. If you implement that manually, that's quite some effort if you have done that before. Another example is tables. We have extensive support for tables, so you can model them pretty much like I've modeled the form. Basically, what you need to describe is which attributes should be shown in columns. And then we have default cell editors, and again, you can plug in your own cell editors if you want to modify certain columns differently. And there is much more. Another example would be a tree master detail view. If you want to present your data in a tree where you can actually add elements, children elements, drag things around, and so on, there's support for that in EMF Forms too, and much, much more. So if you're looking for a particular feature, feel free to talk to me and ask whether it's already supported. If it's not supported, the good news is that this is an open source project. It's an Eclipse project under the EPL. So if it doesn't have a certain feature that you need, you have two ways of fixing that. Either you can contribute something, or you can contract a company of doing that for you. That's what we typically provide to our customers. Now, a final topic I would like to mention before I close my talk is EMF Forms, besides making the development much faster, it provides another advantage, which is a little bit more going into the future of your application. The view model that I presented today has no dependency on SWT. It's a completely abstract format, and this describes your form completely independent on any UI technology. And that means you can render it using SWT, but you can also render it with other UI technologies. As an example, you can also render it in the web. There is a renderer for that called JSON Forms. Or you could even render it in JavaFX. Yes? Yes, so the reference renderer is based on SWT. That means the SWT implementation provides the biggest feature set, while the JSON Forms renderer is ready for production, but it's not, it doesn't have such a large feature set. If you go from, it depends a little bit on from where to where you go. So replacing one single renderer in the same UI technology is really trivial. So for example, to go from SWT to Angular, it is basically transforming your view model into a JSON format, but there is a exporter from that, and you have to take care about the wrapping of your application, because it's a completely different application then. But you can reuse the definition of your UI. That's the most important thing. What you cannot reuse are, for example, custom controls if you implemented them in SWT. So it's typically worth to stick to the default controls as much as possible if you don't have the requirement to do something else, because every line of SWT code makes the transition to another UI technology more effort, basically. About this topic, so we provide a SWT renderer, and this SWT renderer also runs well on web, so you can directly bring it to the web. We provide JSON Forms, which is based on JSON Forms 1 is based on Angular. JSON Forms 2 will not be based on any particular framework. We have a prototype for JavaFX, and we have a running version of JavaFX. Unfortunately, this is not open source because our customer decided to have this in-house. Plus, we have implemented quite a few renderers for other UI technologies. And the thing is, as this UI description is really independent on what you do with it, you could, for example, also render your forms in a document, meaning you want to present the same data in a PDF, we can just interpret the view model differently. So you have a lot of flexibility of reusing this UI definition. Okay, as a quick outlook, there are 3 more events during this conference which might be of interest to you if you like what you saw today. The first one is tomorrow at 2 o'clock. That's a talk about JSON Forms, about the web version of EMF Forms, given by my colleague Maximilian. I will do another talk about EMF Forms tomorrow at 3:45, which will cover a number of more advanced features. So for example, I will talk about input validation, tables, the tree master detail, more advanced layouts, and so on and so forth. And finally, today in the evening at 6:30, there will be above. This is an informal meeting of whoever wants to join and the project leads of EMF Forms. There are a couple of other projects. Reason for that is that those are the same project leads. And I think it will be here, so if you just want to talk to us and you don't find us, you can come there and ask any kind of question. Besides that, I'm happy to answer any kind of question right now. And also, we of course here the whole week at our booth over there, or drop me an email or contact me however you want to ask any kind of question. Are there any questions right now? Yes? Yeah, so I'm not completely into serious tables, but maybe a related question is about the property sheets that Sirius creates. I would say Sirius in general is still focused on graphical editors. So all the features, for example, for the property sheets they provide are typically targeted at property sheets, while EMF Forms is very much focused on business applications. In turn, you can use EMF Forms very well in tools too. I mean, I would say 50% of our users do some tooling. Typically, they have some complex configuration data. Other 50% are business applications. And to answer your questions, I don't really know about serious tables. Yeah. Any other question? I think you were first.
If you have, for example, a dialog where you have values and only want to sync it after the user gets okay, do you have to manually sync the data or does the handle?
Yeah, there are two ways. So the data binding is produced in the central service. You can influence that at one place. So you could either tell the data binding of all controls to only put the data in the model on pressing OK. Or you could directly sync with the model, which would have the advantage that you can directly validate against the model constraints, and then, for example, sync the data afterwards. But that's really up to you. It doesn't really change whether you do it with EMF Forms or not. It's basically the same decision you have to take. And last question? Okay. Then you are the last question. Yes, so you can configure the width of the text field. You can also tell the text fields to be exactly as length as defined in the model. Yeah, this is basically the answer, yeah. But this is really the last question. Yes.
So what happens to the customization that already done on email? Do you override them or how do you manage it?
Okay, that depends a little bit on the model change. If you add stuff to your model, which I would say is typically the case if you evolve a project that you add stuff, you can just extend the view model. If you really, for example, delete an attribute or change its ID, then you need to adapt the view model too. There is a check for integrity, but we don't automatically resolve that view. Reason for that is that we cannot really know, for example, if a certain attribute in the data model is not there anymore. We don't know whether you want to know about this or whether we should just remove. So we don't automatically update that. But I would say most common case is that you have a smaller data model and then you step-by-step extend it. And that's really well supported. Maybe as a final thing to show, if you're missing something in your view model, so let's assume the attribute first name has not been in my first version. There's actually a wizard for that. I can click Generate Controls. It shows me all attributes of a user, and a very nice feature for evolution is I can filter that down to the attributes which are not yet on the form. So that's task before, because I removed it before, and username, and now it's back then. So that's a typical step-by-step evolving, adding stuff case. Okay, so I think I'm over time. Thank you for your attention. Hopefully we see you tomorrow in the other two talks. Thank you.